Okay, let's dive right in. You've probably seen AI getting crazy smart, right? But have you ever stopped to think about how it's actually thinking? Today, we're talking about the next big leap in that evolution, something called hybrid graph RAG. It's a whole new way of teaching AI not just to find facts, but to actually connect them.
And this quote just nails it. Think about it like this. For years, we've basically been teaching AI to be the world's greatest librarian, unbelievably fast at finding the exact document you ask for. But GraphRAG? That's a totally different beast. It's about turning that librarian into a master detective, someone who doesn't just find the clues, but actually understands how they all fit together.
Okay, but why? Why go through all this trouble to build a detective AI? Well, the thing is, for all their genius, today's large language models, they've got a dark side. They're brilliant, but they're also kind of fundamentally broken in some really important ways.
And this right here lays out that brilliant but broken personality perfectly. On the one hand, LLMs are incredible. I mean, they can generate poetry, write code, spot patterns you'd never see. But on the other hand, they have these huge blind spots. Their knowledge is stuck in the past, and worse, they have this really bad habit of hallucinating, which is just a fancy way of saying they confidently make stuff.
So to fix this making stuff up problem, engineers had to find a way to chain the AI to reality, to give it a source of truth it couldn't ignore. And their first big, brilliant solution was a system that acts like a perfect infinite digital filing cabinet.
That system is called Retrieval-Augmented Generation, or RAG for short, and the logic behind it is actually beautiful in its simplicity. Before the brilliant but unreliable AI gives you an answer, it's forced to first retrieve facts from a trusted source. That's our digital filing cabinet. Then it augments its own knowledge with those facts, making it way more likely the final answer is accurate and up-to-date.
But there's a huge flaw in this perfect filing cabinet. The AI can pull out a file on person X, and another on company Y, and a third on project Z. No problem. But it has absolutely no idea that person X is the CEO of company Y, and that she's the one who led project Z. It just sees separate, disconnected files. The web of connections between them, totally invisible.
And that is the missing piece of the puzzle. See, we don't just need a filing cabinet of facts. We need a blueprint that shows how everything fits together. And that's exactly what a knowledge graph is. It doesn't just store information, it maps out all the relationships. Who works for whom, what product came from what company. It's the blueprint that finally lets the AI see the big picture, not just the individual bricks.
And this is where we get to the real masterstroke, hybrid GraphRAG. This is the big idea that combines the best of both worlds. You get the super fast retrieval of that filing cabinet, but with the deep, contextual understanding of the blueprint.
So if there's one thing to take away, it's this. Hybrid GraphRAG doesn't just find facts, it reasons across them. When you ask it a really tough question, it can literally walk across that blueprint, following the threads from one piece of info to the next to build an answer that a simple search would never, ever find.
And the way Microsoft built this is pretty genius. First, it has an LLM basically read everything and build that blueprint automatically, pulling out all the people, places, and how they're connected. Then, it uses something called community detection to find clusters of related stuff. And finally, it uses that super rich map to let you search in a way that's, well, truly intelligent.
And this image is a perfect example of that second step, community detection. Think of it like you're reading a massive fantasy novel. One of these colored clusters might be everything related to one noble house in their capital city. Another cluster could be a totally separate storyline happening across the sea. By spotting these communities, the AI can actually understand the major themes and plots in the data, instead of just getting lost in all the tiny details.
Okay, so the theory is fantastic, pure genius. But a great idea is totally worthless if it's too slow to actually use. And when engineers tried to take this from the lab to a real-world product, man, they hit a brick wall, a massive one.
And this is where reality really hit hard. I mean, just look at these numbers. An early version took 25 to 30 hours to process just 1,000 documents. At that speed, the system wasn't just slow, it was a complete non-starter. You couldn't use it for anything.
So this became the big make-or-break question for the engineering team. How in the world do you take a process that takes more than a day and make it run in basically real time? Well, the answer, it turns out, was a whole bunch of really clever engineering hacks.
They really attacked this problem from every angle. Instead of just blindly chopping up text, they developed semantic-aware chunking to keep the meaning of the sentences together. Instead of making zillions of tiny, slow database calls, they used intelligent batching to bundle them into huge, efficient groups. They figured out how to process related data together and load everything at the same time, in parallel. Each one of these was a small win, but when you put them all together, they turned that 30-hour nightmare into a sleek, fast, production-ready engine.
So, the engine's built. It's fast, it's powerful. But now it's time for a little dose of reality. It's really important to see where this technology is right now and what the real vision for the future is.
And this quote right here is that reality check. Turns out, for all its power, studies show that GraphRAG can actually be worse than the original, simpler RAG on a lot of tasks. Why? Because for a simple, straightforward question, all that complex graph stuff is just overkill. It's an amazing tool for sure, but it's not a magic wand, at least not yet. But that limitation actually hints at the true endgame here. The big vision isn't about building one perfect, rigid system. It's about building a system that's smart enough to improve itself, one that can learn and adapt and pick the right tool for whatever job you throw at it.
And that future has a name: Agentic Optimization. Imagine there's a master mechanic living inside the system. When you ask a question, this little intelligent agent looks at it and decides the best way to get the answer. Is it a simple question? Okay, I'll just use the fast filing cabinet. Is it a super complex question about relationships? All right, time to roll out the blueprint and start tracing those connections. It's a system that picks its own strategy and tunes itself on the fly. Basically, a self-improving knowledge engine.
So what we're left with is this really big question. This whole journey isn't just a technical upgrade. It's a fundamental change in what we're even asking AI to do. Are we just teaching it to be a better fact retrieval machine? Or are we actually teaching it to truly understand the web of connections that gives those facts their meaning? The answer to that question, well, that's going to change everything.